Hey, this is Don from Padlock Technologies again with another question. This one is more of an advanced question that someone wants to, they want to learn about the technology. So what is the technology that this question is on? It is very simple. Now I heard, you might have heard me say this a whole bunch of times here. It is, let's do the headline, MP-BGP, EVPN, I'm gonna say MS for multi-site. That's a whole lot to say. Basically what this technology is. So this is the same technology that ACI, they used to call this DCNM, but I think it's called Nexus Dashboard now. All right. This is the same technology this does. All right. Now, SDA kind of does similar, but VXLAN is the data plane, but Lisp is the control plane. The key thing between SDA and this MP-BGP EVPN or ACI or Nexus Dashboard is this key here. Because the control plane, again, is Lisp and SDA. ACI control plane is BGP, right? EVPN, stuff like that. So how does this, work from a theory standpoint? Now, I've already created a lab about this, and I'm going to show you the lab after we explain this theory. The next video would be the lab that shows you this theory. But let's go over the theory for one, right? So let's say, what is the point of all this? So let's say you have two data centers, right? And we're going to have spine. This is called a clause fabric, right? And if you don't know what a clause fabric is, it's just spine leaf, right? Spine leaf, right? So then we have a DCI in between, data center interconnect. This could be dark fiber. This can be whatever you want to do, right? And then we have another data center over here. All right. Same philosophy. And we're going to say spine and leaves. Okay. Now, I will tell you that this leaf here is very important when it comes to the multi-site, right? Because you're going to connect in to your DCI. And then this is where the stretching of the VLANs come, or the layer 2 segments, but VLANs come into play, right? So let's say you got some workloads down here connected to the leaves. I'll just do here. You can technically have stuff connected here as well. You don't have to, but let's say you have workloads here. So the whole point of this whole technology is basically, let's say you have VLAN 10 over here, and you can have VLAN 10 over here. Now, this VLAN 10 is going to be stretched over both data centers from an L2 perspective. So this is the L2 stretch. And hopefully I spell stretch right. This is the L2 stretch. So technically, all these, let's say this was 1/1/32. This was 10/112/32. This was 10/113/32. This was, and we're just going to go down the line here. 4, 5, and 6. Now, doesn't really matter, and I'll do this here too. Now, doesn't really matter that these workloads, and you would typically do this if you're in a data center and you have your workloads here. Doesn't really matter that these workloads are, from a physical standpoint, in two separate data centers. They don't care about any of that because ultimately these devices look like they're in one big switch. So they look like they're literally sitting in the same data center from a logical standpoint, right? So when I want to talk to, so if this workload wanted to talk to this workload, it would go over this DCI and talk as if they were sitting right next to each other. Now, how does that happen? The key here is when you do the EVPN between these two, the borders, they're going to share a type 2 route, which is a MAC IP binding, right? Now, this is still all tunneling and all that good stuff. And when we go to the lab, I'm going to give you a little bit more detail, but this is just a high overview theory here. So this is going to be a type 2 route that's going to be shared between the border nodes here, are these border gateways, right? That's what they're technically called. These ones that's in red, or I have circled in red, are called border gateways. And these border gateways are going to share type 2 MAC and IP information between the two sites respectively, right? Now, in each DC though, you're going to run like multicast here, right? So multicast is what you're going to use. You don't have to, but it's recommended, right? Because you don't want to do ingress replication within the data centers, because ingress replication, that's headed replication. That means the VTEP, and these are called VTEPs. The leaves are called VTEPs, right? The VTEPs would have to make a copy of each packet and then send it to each VTEP in the data center. Just use multicast for that. Just eliminate the whole multicast. Eliminate the whole ingress replication within the data centers. Now, between data centers, you don't have an option. Between the two data centers, you have to do ingress replication, right? You have to do that, right? And what does that mean? Well, when that packet comes in and it needs to talk over to the other data center and emulate that layer 2 stretch, it needs to send that packet to whatever border gateways. Now, this is only one border gateway, but you could technically have two. You can have, well, I want to have three. You could technically have two. And when you get into two, you have to deal with this thing called a designated forwarder, right? And this happens when you do VPC as well. And in the lab, when I show you, I have VPC on both ends. So when you do VPC, the designated forwarder, let's say, I'll just put another leaf right here, right? And let's say VPC, this is a switch down here, and now this box goes into that. Well, when the packet comes in and you're using VPC, the designated forwarder basically says one of those VTEPs, one of those units is allowed to forward the traffic. The other one, when that traffic comes into it, it just drops it. And why do they do that? Well, it avoids duplicate packets, right? Well, if both nodes or VTEPs were allowed to send the traffic once it receives it, then you're receiving duplicate copies of the same packet. Same thing on the border node. So if you have a border, you have the border gateways. If you have those in a VPC configuration, and then a couple designs here. This one is a DCI design. If you do back-to-back VPC, which is mean there's a VPC on both ends and then they're directly connected, well, now you have a weird kind of design, because not only does the border gateway needs to be directly connected to the other side, it also has to be connected to its other VPC peer in a layer 3 link. The back-to-back VPC design, I don't really like per se. I would rather do this way with the initial DCI, you connect everything in, and then you run it from there. Now, there are some things that you're going to get burned on if you're not careful. For one, to do all this, the MTU needs to be 9216, I believe. Yeah, 9216. If you don't do that, VXLAN, this BGP EVPN multi-site will not work, because there's a lot of jumbo frames that you need to have. If you're just using the MTU 1500, it's not going to work. Traffic won't even go through. And I've been burned on that a couple of times. So I'm just telling you right now, all your links in your data centers should be 9216, right? Especially if you're going to do something like this. Now, if you're doing some kind of L3 out, that's an ACI term, but if you were going outside, then you may not need that. You can do the 1500s perfectly fine, but I like to be 100% across the board, cohesive. So we're just gonna make sure it's 9216, right? Especially on this DCI. And the DCI is where you're gonna get burned. Because if your DCI doesn't allow you to do 9216, they may come back to you and say, hey, I can only do 9100, which I had a problem with that when I did a project for a client. They could only do 9100. Luckily, 9100 worked, but I would prefer it to be 9216. And that's just based on best practices, right? Now, you would do this type of situation, and that's the next logical question. Why would you do something like this? Well, two things. Number one, there's no spanning tree in the data center, right? Why would you not have that spanning tree in the data center? A spanning tree is a very old protocol that, Cisco and other vendors have tried ad nauseum to get rid of. First, it was Fabric Path and Trill, which is just, Trill is just Fabric Path, but open source or open standard, right? Then it was OTV, and now this is like the de facto standard here, which is just VXLAN. Now, BGP obviously is the control plane for this, but there's no spanning tree in your data centers. And why does that matter? Because a lot of these links, man, these are 100 gig links. Like, let's be for real. These links could be 100 gig links. Do you really want to block a 100 gig link? 100 gig link, I think they were like, I can't even tell you how, especially if you get twin X. If you get like twin X cable and stuff like that, 100 gigs, and you may have to, I don't know if twin X goes up to 100 gigs. So don't quote me on that. Because I know you could get, multi-mode fiber and get a 100 gig transceiver and stuff like that. But to have all that, that's a lot of money. And you can't really afford to be blocking links. Now, you might say, oh, you can port channel and all that good stuff. Here's the problem. It's still layer 2. And as I said in my previous videos, the one thing that you need to worry about, and I've seen this melt a data center one time, is layer 2 loops. You configure one thing wrong at layer 2 and you can have an infinite loop because there's no TTL value in layer 2. There's a TTL value in layer 3, only 255 hops, and it just drops off. But layer 2, that loop could just keep going and going and going, completely melt your network. And now you're like scrambling and unplugging stuff because, oh, I don't know where that layer loops come from. Now you could look at your topology change notifications, which is your TCN values. You can look at that and see, what's going on over there, what's causing the meltdown. But you don't get a lot of advantages of doing layer 2 in a data center nowadays. Plus, you can take advantage of ECMP and multicast and all that stuff. The bum traffic is not there anymore. You could do ARP suppression here, which is you don't have to worry about sending that ARP out or in multicast because there technically is no broadcast. Once it gets up to once the broadcast gets to the VTEP, it kind of sends it in multicast, and then the people that are in that multicast group receive the broadcast. So it doesn't broadcast it everywhere. So yeah, this is, do most people do this to stretch VLANs? It really depends, right? Because here's the thing. You can have an active data center doing this, right? Now, if you have active data center, you just got to be careful because you got to worry about like asymmetrical routing and stuff like that. Especially because if you're doing BGP to the other ends, you may have to manipulate the path and stuff like that, or manipulate some values so that you don't run into it. But you can avoid all that if you do this thing called redistribute HMM. So if you redistribute HMMs, those are technically the /32 routes. And if we're talking about longest match, well, longest match when /32 is the longest match of everything. It doesn't go really past that. So as long as your routing table is now full of /32 routes, that is the con of that. So you may not want to have all those /32s in there. But if you do this HMM now, when you move a resource, let's say I move, 2 from this data center and I, do a VMware, something in VMware to just move it over here like a vMotion, and I moved it over to here. Well, if I had something upstream, it would now see that, hey, 10.1.1.2 is no longer in data center 1, it's in data center 2. Right, BGP would update and you would see those routes coming there, and you'll see it in the lab. Now I can't do vMotion in the lab, obviously, but you'll see in the lab where the slash 32s and everything is coming up from there. What else is there I can tell you about EVPN? Multisite. This is going so here's something that burned me in the past. So between the border gateways and the DCI, you're going to be running normal BGP IPv4 uniclass, right? And then between the border nodes, you're going to be running EVPN. So you're going to be running EVPN on top of IPv4. You're not going to establish an IPv4 relationship and an EVPN relationship between the border gateways, because then it will start flapping, because it says, hey, I see it here coming in this way from IPv4, but you're telling me it's an EVPN. That burned me a couple of times, and I spent 12 hours at a data center just because of that. And honestly, that wasn't in the manual. That wasn't in none of the books or the writing or anything. And I had a nice little conversation with Cisco to say, hey, you need to update your documentation, because that's not in your documentation. And we just spent 12 hours because of this. So they updated the documentation and got it fixed. So now that's been updated and all that good stuff. But yeah, stretching layer 2, having active. Let's say you had like a Zerto or something like that, and they needed to be technically on the same. They didn't need something that needed to be on the same layer 2 domain, but you wanted to have them geographically spread out in 2 different data centers. This is what you would do that for. This entire technology, what you would do that for. Now, ACI automates this, right? But here's the thing about automation. If you don't know how it works under the hood, if something automates it and it goes wrong, you kind of don't know how to fix it. If you don't have a kind of base understanding of how MP-BGP EVPN works or multi-site works, when ACI does it, you're kind of like, all right, well, ACI just handle it. Now, the difference with ACI, they have this thing called a MSO, which is a multi-site orchestrator. And the multi-site orchestrator, let's go to another thing. I'll do this. So ACI, MSO, all right? So from the MSO is the overarching component, right? And then in data center 1, you would have your APICs, your 3 APICs, right? APIC, you always want to have 3 of them. APIC 1, 2, APIC 3, all right? And this is data center 1, DC 1. And then in DC 2, I know I'm side questing right now, matter of fact. I know that, so bear with me here on the side quest. So data center 2, we have another set of APICs and so forth and so on, right? You have data center 3, 4, whatever. So what the MSO does is it hooks into these APICs, right? And then you can orchestrate your multi-site environment through the MSO, right? So you can do everything I just showed you in the last slide kind of automagically. Now, I say semi-automagically because the MSO kind of handles the networking piece, the overarching networking piece, right? Which are, let's see here. They're your bridge domains, your EPGs, stuff like that. So you handle the basic constructs, right? Interface configurations, though, that's handled at the APIC level. So you still have to go into the local APIC and kind of configure that stuff. You have to configure your, physical or logical, your AAEPs and stuff like that. Well, AAEPs ties the logical to the physical, right? The physical interface. You still have to go in there, and there's a couple other things you have to do. Just trying to remember. Oh yeah, you got to define your domains, right? And you could have a VMM domain, which is VMware, or your physical domain. You have to do your VLANs, which is a container, basically. You have to do all that still at the individual APIC. But when you want to do like your bridge domain, your networking piece is, okay, what's the EPG that we want to call, what's the bridge domain that we're going to put it in, and then you have to tie those physical interface configurations into some EPG, right? You do that at the MSO level, but you still have to have those interface configurations there. This is the number one confusion part about ACI and MSO, because everybody thinks that, oh, I got the MSO, it's a go, man, we do everything in here. Nope, not happening. You do some stuff in the MSO, and you do some stuff in the APIC individually. So that was a side quest, but that was MP-BGP EVPN multi-site. That is a long thing to say, but that is what that is at a theory in a nutshell. And then I gave you a little bonus about ACI MSO and how that kind of works to mimic what you would do manually. Next time we see me or we talk, I'm going to go into the lab. I'm going to show you what the multi-site configuration manually looks like. Now, I'm going to warn you right now, the data plane does not work on these images, but we can validate that the MAC address and type 2 routes are being seen, because just the image just doesn't do it. You need a certain ASIC to be able to do it, right? And because I'm using a virtual environment, there's no real ASIC for me to actually demonstrate data plane in the multi-site configuration. Now, within the data center, ping works perfectly fine. Multi-site doesn't work because the data plane is not there. So hopefully that was informative. Don't forget to share, comment, like, and subscribe. Keep sending me those questions. I'll keep giving you answers. This is Dom from Padlock Technologies. Thank you. Have a nice day.